Hello, on this series of mathematics, I'm going to talk about the questions from the Algebra 1 2017 release questions for the STAAR, the Math STAAR, Algebra 1 STAAR. First thing I want to do is talk about the reference materials that will be in the front of your Algebra STAAR book. And it's important that you understand how to use them. The first top section, we have factoring, then we have properties of exponents, then we have linear equations and quadratic equations. In the first section here, we have perfect square trinomials. And if we notice, if you look in the perfect square trinomials, we have this section here and we have this section here. The difference of squares, we have the two perfect square trinomials. The only difference between these two is one has all pluses and the other one has minus. So if you see a quadratic equation that is, say for example, let's say we have x minus 2 and that's squared. That's a perfect square trinomial, and that's the one that's here. That's the second one here. Now if you see something that looks like, let's say, x plus, let's say, 3 squared, then we know that that's this first one here. And in terms of looking at it, if you look at this here, our a, it has a squared, which is, that's the first term in that series. So if I'm talking about the first one that I did, the x minus 2, that would be x squared, and then minus 2 times whatever the value of a. Well, the value of a is x times the value of whatever the value of b is, which is 2, plus b squared. And so the value of b is 2. All right, then we're just going to square that. Straightforward and that simple. All right, you're given that formula, so it shouldn't be that difficult. It's just a matter of plugging in the values and simplifying to get what your trinomial should be. The second important one is called the difference of squares. All right, we went over that in class, and that was called the product of a sum and a difference. The most easiest way to, vocabulary-wise, is the difference of squares. The difference being is that we have a subtraction here, and both the a value and the b value here are both perfect squares. So, for example, let's say I were to give you the problem 4x squared minus, let's say, 36. Okay, well, that's the same thing as saying 2 squared, and then we have x squared, minus 36 squared is 6 squared. Okay, so that's what that is saying. That's saying the same thing. Whatever's in your a term and whatever's in your b term has to be a perfect square, and we have to have a difference there. All right, so then we would write this out if we were talked about in terms of talking about factoring, right? Because we say factoring. We're not talking about solving, but we can, by factoring, we can then solve. All right. Now, so I would write this out. This would end up being 2x minus 6 times 2x plus 6. If I were in the terms of talking about factoring that and taking the difference of squares. All right. Now, the next section, we have the properties of exponents. And this is, we have the products of powers, the quotient of powers, power to a power, rational exponent, and the negative exponent. It gives us the rules. It should not be any more difficult than that. Product means to multiply. Quotient means to divide. Okay, power to power means that I'm taking something like here. It says a to the power of m, then the whole thing is to the power of m. Now, I have to remember, when I'm multiplying and taking a power to a power, these end up getting multiplied. Here, when I'm multiplying powers, and so, in other words, I have a to the m power times a to the m power, my bases are the same. If my bases are the same, I can add the exponents. Now, if they're not the same, I can't do anything with those. And same with the quotient, or when I'm dividing. Okay, if you notice, both the bases are the same. So, if the bases are the same, and I can subtract when I'm dividing. Okay? Rational exponent gives us our rules here. A to the power of m over n. If I were to take that to radical form, whatever's in the denominator, that ends up being the root of whatever your square root that you're taking, or the radical that you're taking it of. That's the index term. Okay? Oops. Don't want to stop recording. Didn't mean to do that. Now, whatever the m value is, so whatever's in the numerator is going to get put above the radicand as the power. Okay? And then a negative exponent, that is just explaining if I have something let's say 2 to the negative 3, then I would write that to be, well, it says my n value, so I'd end up taking this 1 over 2 to the third power. Everything gets moved to the bottom if it's a negative exponent. All right? So whatever I have in that n place gets moved as an exponent, it becomes a positive, and the whole thing becomes moved to the denominator. Linear equations, we have standard form. Ax plus by is equal to c. Has to be, or let me rephrase that. Can't be fractions. We cannot have fractions. I'm just going to use improper terminology. Can't instead of saying cannot. Can't have fractions. All right, slope-intercept form. Y equals mx plus b. We need equations to be in this form to find our slope, our y-intercept being b, and that is when x is equal to 0. Point-slope form. So if we're given a point and we're given a slope, we use point-slope form, and then we move it into slope-intercept. All right? The y1 and the x1 represent a specific number. Note, the formula says that the minus, that's negative y1 and negative x1. So if your value that you're given, let's say I give you the point -2, -4, my y value is going to become positive, and my x value is going to become positive as well. So pay attention to signs in that situation. Slope of a line, that's y2 minus y1, x2 minus x1. All right, rise over run. So this is our rise over run. The x values go on the bottom because you're going left to right. You're running. And up and down, your rise, that's your y values, that goes on top. You can also think of that, whatever, your rise is going to go on top, and your run's going to go on the bottom because they're flat. Quadratic equations gives us standard form. Vertex form gives us vertex form, our vertex being at h and k. And we're given quadratic formula, and we're given axis of symmetry. X is equal to negative b over 2a. Now you need your axis of symmetry in order to find your vertex if it is in standard form. Either way, also you need to set the equations equal to 0. All right. Now let's go ahead and go to the first page. Biggest instruction that I can tell you, just like they say here, read each question carefully. For multiple choice questions, determine the best answer to a question from the 4 answer choices provided. For a gradable question, determine the best answer to the question and fill out the answer on your document. Question number 1, which expression is equivalent to the square root of 147? Well, 147 is not a perfect square. So that means, but I want to look at the perfect squares that go into 147. We know that we have 1 times 1 is going to be equal to 1 squared. And we have 2 times 2, which is equal to 2 squared, which is equal to 4. Okay, and we have 3 times 3 is equal to 3 squared, which is equal to 9. Okay, so I know that if I would take the square root of 9, that would be equal to 3. The exponent and the radical cancel out. Well, I want to see of my perfect squares which one will go evenly into 47. So I'm going to try, let's try 4. Okay, 4 won't work. So now we're going to try 9. 9 won't work. So now we're going to try the next one. We're going to try 16. 16 won't work. Well, I'm going to use a hint here. It's given me part of these. Okay, if I look at the numbers that's left in my radicand, I'm going to use that to so I don't have to sit here and play with all the different values. So I'm going to try 147 divided by 7. That gives me, that would be 7 times 21. But 7 times 21, that's not a perfect square. 21 is, or neither one of those numbers is a perfect square. Now, there's a perfect square that will go into 21, but that won't work. So I can actually eliminate those 2 answer choices right now. Right now, let's try 3. 147 divided by 3. Okay, 147, the square root of 147, I can rewrite that to be the square root of 3 times 49. Well, the square root of 49 will give me 7. So remember, I want to take the square root of 3 times the square root of 49. That's going to give me the square root of 3 times 7 when I take out care of the square root of 49. Now, the rules say that I can move that in any order since we're multiplying. So I'm going to say 7 times the square root of 3. What's our answer choice? B. Number 2. It says a drummer and a guitarist each wrote songs for the band. The guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. The total number of songs is 46. So we know that the drummer plus guitarist is equal to 46. Okay? And we know that the guitarist, so G, is equal to 8 fewer minus than twice the number of songs that the drummer wrote. Okay, so let's see which answer choices make this. So it might work there. So then here we have, this won't work because that won't match our D plus G. So our answer choice is really in, this won't work either. So our answer choice is going to be either F or J. So let's look. We have D plus G is equal to 46. Okay. Then we have D is equal to 8 minus 2G. But that's saying that the drummer songs that the drummer wrote is equal to 8 fewer than twice the number of the songs that the guitarist wrote. So F has to be our answer choice. And I'm going to go over the next page on the next video. I don't want this to get too long. See you then.